Right, so here we go with CCEA, A2 Physics, Unit 2, Fields, Capacitors and Particle Physics for June of 2018. Let's get started. Question 6a, define electric field strength. So electric field strength is the force per unit charge, so it's the force at a particular location. The electric field strength will be the force on a single 1 coulomb charge at that location. Part B then, figure 6.1 shows 2-point charges Q1 and Q2 of plus 25 microcoulombs and plus 15 microcoulombs placed at a distance of 2 meters apart in a vacuum. Calculate the magnitude and direction of the force exerted on the 0.25 microcoulomb charge. So the force between these, we have an equation for it. F is 1 over 4 pi epsilon naught Q1 Q2 over r squared. And so 1 over 4 pi epsilon naught is this 8.99 times 10 to the 9 figure. Q1 is 25 times 10 to the minus 6, Q2 is 15 times 10 to the minus 6, and R is 2, so it's 2 squared on the bottom. And that comes to 0.84. And if we remember that these are repelling, then the forces are equal and opposite. So the force on the 25 is to the left. Part 2, the resultant electric field strength is 0 at a point Z, a distance x from Q1. Calculate the magnitude of x. So I've just brought this diagram back in. So point Z here is a neutral point, which means that the field due to the 15 pointing one way and the field due to the 25 pointing the other way are equal and opposite, so that they cancel. So if this distance is x, this distance here is 2 minus x. So we have a field due to the 25 pushing this way, we'll call that E1 because it belongs to Q1. We've got a field due to the 15 microcoulombs pushing this way, we'll call that E2 because it belongs to Q2. And E2 and E1 have the same magnitude. So E1 would have a value of 1 over 4 pi epsilon naught times Q, which in this case is 25 microcoulombs, over R squared, which in this case is x squared. And E2 would have the same form, only we would swap the 25 for a 15 and swap the x squared for a 2 minus x all squared. Now if you put these equal to each other, these terms here are going to vanish and you're just going to be left with this versus this. And obviously these 10 to the minus 6's will cancel as well, so you can just leave in the 25 and the 15. So you just get this. So we end up with this quadratic, just multiplying out this bracket here to get this stuff, and then taking this 15x off. Now that solves by the quadratic formula, which would look like this. And that gives two values of x, one at 8.87 and 1.13. So this answer is meaningless for our situation, so it has to be this one. And so x equals 1.13 meters. And that's it. Now, just in case you're wondering why we discarded that second result, I've plotted the two fields here. So these are our two charges, one at 0 meters and one 2 meters out, and these are the fields belonging to them coming out in both directions from the charges. This is the point between the two charges where they become equal in magnitude. Now they're opposite in direction, but we're not showing that here. But this is where they're equal in magnitude. This is the solution we're finding. So this is the valid solution that's between the two charges. Out here somewhere, at about 8 meters, they become equal again at a location here. But that is of no interest to us, because not only okay, they do become equal at this very low value, but they're both pointing the same way. At this point that we're interested in, they point in opposite directions. Sorry. The green one's pointing that way, the blue one's pointing that way, so they're equal and opposite. They actually both point the same way out here, so that is of no interest to us, that second value. And so these are the solutions to the quadratic. There's a solution to the quadratic here somewhere, and there's a solution to the quadratic out here somewhere. But it's this one that we're interested in because it's between the charges. Okay, thanks for watching.